Welcome to this lecture. In the last lecture, we just started discussing about ternary association. We so far discussed about the association class, the unary and binary association. Those are very common, but occasionally we also need to use the ternary association. Quaternary association is less common, but ternary association in many modeling problems you might see here that three classes are associated. Here the name of the association, here we represent this in a diamond symbol, the ternary association, and the name of the association is Mary. Possibly I could have written Mary here on the top of it, that might have been more sensible. So the name of the association is Mary, and man marries woman, marriage performed by up to 3 priests. And we can have quaternary association where we can add another class to this. For example, witness. The marriage was witnessed by specific persons, so we can have witness here, star the cardinality here. But how is the ternary association implemented? To implement the ternary association, we decompose it into a set of binary associations. For the example we discussed just now, we have this name of the association is made into a class here, marriage, and on the object for the man class, the link is established to marriage, 1-1 link, and woman to marriage, 1-1 link. So that is a marriage object of man, let us say A, marriage object M, and we can have we can have several objects on the man, A, B, C, and we can have woman, L, M, N, and we will have different marriage objects created, M1, M2, M3. Let us say A married N, and we have this link, 1-1 link with the M2 marriage object. M1 marriage object is between, let us say, B and L, and then we will have let us say there are 3 priests, P1, P2, P3 are the objects, and we will have links here established between marriage and the priest. Maybe 2 priests married of B and L, so there will be link to 2 priests here. So that will be the object diagram for this, and we know that this we can implement easily. We have so far discussed about binary association implementation, unary and binary association implementation. We can very well implement that. Now let us look at the quaternary association. Here is a quaternary association. A football team has 11 players, and the team and the player association, this team, one team and 11 players of that team they play in many seasons. But of course, the players for different seasons may vary. The team, for the same team, maybe different players play in different seasons. But given a team and a set of players that play there, for the different seasons, we have different records of goals against and for that team. We would like to maintain that. And then we will use a quaternary association and we will implement this in the form of a 4 binary association. Since these are not very common, more than 3 or 4 associations, we will not spend time on this. Let us move on to other types of relation, but before we move on, let us have a small quiz. Let us say we represented an association relationship between a book class having these as the attributes of the class, title, editor, and we have the editor class having attributes name and my books, and we represent the association relation. Write the name of the association, edited by, book edited by single editor, but the same editor can edit multiple books. Now the quiz is, given this situation, please identify, are there any notational problems in this UML class diagram? Are there any notational problems in this UML class diagram? We have so far looked at the class diagram involving association relationship, binary, unary, ternary, and so on. Let us identify what is the mistake in the modeling here, because if we know the mistake, we will not commit those mistakes. The first mistake here is that these are implicit attributes. We do not explicitly write here the editor is an implicit attribute of the book. We do not explicitly write that, that is understood. Once we implement, those will appear in the code, but in the class diagram we do not explicitly write that editor is an attribute of the book class. The second problem is the arrow type is wrong. It should not be a filled arrow, it should be a open arrow. So these are two major problems here in this association class diagram. Now let us look at qualified associations. Sometimes in an association relation we would like to be more expressive than what we have been doing so far. Let us just look at that. Let us say we have a simple association between a class and a student. A student belongs to a single class, but a class can have multiple students. Binary association, simple, but let us say we want to be more expressive. We want to express that there exists up to one student with a given roll number in a class. Given the roll number, we can uniquely identify the student of the class. Or a directory has many files, but given a file name, there can be at most one file in the directory. Let us first see how to read this, then we will see slightly more details of this. If we have, this is the qualified association, This is the qualification of this association. In the qualified association, we say that there exists up to one file, 0 to 1, there is up to one file for each instance of file name in the directory. Of course, there can happen that a file name exists, but there is no file associated with it. It's dummy. But then, given a file name, you can uniquely identify the file. There can be at most one file with that file name. So that we express with this. Given a class, for a given roll number, there can be at most one student with that roll number. Maybe for a roll number there is no student, but then given a class, there exists up to one student for a given roll number, or each instance of the class will have at most one student with a given roll number. Let me just read again the way we read it. There exists up to one file for each instance of the file name in the directory. There exists at most one student for each instance of roll number in the class. Now, let us look at another example. Let us consider that an order for a company has many order lines. Each order line identifies the product that has been ordered for the company and the quantity and so on. But let us have, this is the class diagram for this. An order has many order lines. You just draw here, order is the class, order line, and each order consists of many order lines. Each order has a line item and multiple line items. Now, we want to be more expressive. We want to express that there is at most one order line in the order for each instance of the product that is ordered. That means that there will be no two instances of the order line for the same product. Given a product, there is at most one order line in the order. How do we express that? We will use the qualified association. See here, the star here is become 0, 1. In the qualified association, it is understood that an order has multiple order lines, but then just see here this association here, the link is between the product and the order line, and therefore we say that given a product, in the order we have at most one order line. There is at most one order line in the order for each instance of the product, or given a product, there is at most one order line in the order. If we observed that given a association like this, the star becomes here 0 to 1, at most 1, and then the one which uniquely identifies the object instance on the star end, we write that in the qualified association. For example, a league has many players and the player is uniquely identified by the nickname. That is, given a nickname, there exists at most one player in the league. As you can see that this is more expressive compared to the other diagram. We are expressing here that given a nickname, there exists at most one player in the league. That is, no two players can have the same nickname. And this is a hint on the implementation. We should avoid somehow that there are no duplicates in the nickname exists in the implementation. We should preclude or avoid any chance of having duplicates. How do we do that? Let's see the implementation part here. To implement a qualified association, we use a map, that is a collection class. Given a key, it uniquely identifies the object and ensures that the keys are unique. So, to implement this situation, that given a nickname, there exists at most one player in the league. On the league class, we need to keep track of all the players on the league. So, we use a map here, and now when we want to add a player to the league with a given nickname, this is the add player with the parameter nickname and the player object and the corresponding nickname. We first check all the players that are there so far. It is on the players that contains key nickname that tells us whether the nickname exists or not. If there is no player with the given nickname, then we add that players.put nickname and p into the map players. If there is a nickname exists already, we will not add that, and this ensures that there is at most one player with a given nickname. And for the player class, we don't have to do anything special. There is just a simple association. Each player plays in a league, so we keep track of the league that he plays. Now, let's just do this exercise. A company employs many persons, and the role here, company is the employer and person is the employee. Or we can also read, a person works for a single company. But then let's try to be more expressive. We want to express that given a employee ID, the person can be uniquely identified. That is, for a given employee ID in the company, there is at most one employee in the company. We will use the qualified representation. On the person, on the company end, we will have the employee ID, and we have 0 1 here instead of star. Star has become 0 1, and given an employee ID, there is at most one person in the company with that employee ID. There are other examples. While solving a problem, we might come up with more situations where we need the qualified association. A bank has many accounts, but given an account number, the account is uniquely identified. So here it is more expressive than a bank has many accounts and each account has account number, but we want to be more expressive, saying that given an account number, there is at most one account in the bank with that account number. And to implement the qualified association, we will use map and hash map, and we will check once the account number is generated, while adding an account, we will check whether already such an account number exists. And also, since the implementation is a map, while accessing an account using the account number, the access mechanism is very efficient, because it is not like an array list where we need to check through all the accounts in the bank. There may be thousands of accounts. We do not have to do a linear search or something. We just use the map, and given the account number, we automatically identify the corresponding account. So far, we looked at the implementation of association over last few sessions, and also we looked at the ternary and quaternary association. We looked at how to implement a one-one association. That was the simplest case, and we said that an implicit attribute on both objects that are linked due to this association is enough. And we said that the roll numbers, the roll names actually become the attribute names, the attributes that are implicit. And then we looked at one-to-many association, and we said that this a case tool translates into a vector or an array list, and while we write manually the code, we would use, given a one-to-many association, we will use a vector or array list. And qualified association, it will translate to a map or a hash table. But before we conclude our discussion on associations and look at the other relations between classes, the thing is that once we know a technique, we tend to overdo that. For example, a person and the person's information, person has name and person's information like address, email, birthday, etc. We should not create two classes here, the person's information and person, and set up a one-one association. We should have these in the same class, because these are uniquely belong to this person. It's inefficient, more complicated to have a one-one association between these. Rather, we would have that in the same class. So this is preferable. Let's not overdo the association. So far, the class relations, we looked at generalization, that was the inheritance relations, and we found that it was the simplest to implement in Java code by using the extends keyword. And then we looked at association. We looked at the binary association and n-ary association in general, the unary, ternary, and so on. And then we are trying to be more expressive. We looked at association classes, qualified association, and so on. But now let's look at a special type of binary association, which is aggregation, and composition is a special type of aggregation. Let's now start discussing about aggregation and composition, and after that we will look at dependency, which is another different relation. Even though we said that there are four types of relations between classes that are possible, we said that generalization, specialization, association, aggregation, composition, and dependency. But as we will discuss now, aggregation is a special case of binary association, something more than binary association. It is a binary association. Aggregation is a binary association, but then something slightly more than that. We will see what is more. And composition is a special type of aggregation. It is a aggregation. Composition is a aggregation, but then slightly more than that. We will see that what is different. The aggregation relationship represents a whole part relationship, that is, given an object, it might contain other objects. We represent that in an aggregation relation, represented by a diamond symbol like this. Given a company, it employs many persons, and a person is a member of one club. A club has many persons as member, and a person is employed by a single company. One of the difference between an aggregation and plain association is this one, that the aggregate object is responsible for creating its component objects. As we proceed, we will see this in more detail, but this is the crux of the difference between an association and an aggregation. Just see here, the person and the club, there is also one star association, but here the club does not create the person. The person is created by the company. The person object, the new is called by the company method. New person is called by the person of the company method. But other than that, an aggregation is also an association and often indistinguishable. This is a very subtle distinction between aggregation and association. And of course, we can identify one more difference, that typically the aggregate object invokes the same method on all its objects in a loop. The same operation is invoked on all objects, person objects. For example, let us say a company wants to print names of the employees, or maybe disburse salary, and so on. It will invoke on all person elements. And we also say that since the company creates the persons in the code, we say that the company is the owner of the person. Here in this association, the club is not the owner of the person, does not create it. Here we say that the company is owner of persons. Even though it is owner, but it shares this person with other classes. We are at the end of this session. We will stop here, and from this point onwards, the aggregation and composition relation will continue. Thank you.